Howdy students, this is Unit 12, Water and Solutions. So in this video, we're going to talk about liquid water and its properties. So the first thing we want you to know about water has to do with its molecular structure. We want you to know that water has polar bonds, and that's due to a difference in electronegativity of 1.4, because we have a hydrogen next to an oxygen, two lone pairs, there's the dot structure, and the bond polarity between this hydrogen and oxygen is 1.4, which puts it in the polar covalent region. Water is a polar molecule because it has these lone pairs. It is a bent shape. There is no symmetry, and so we have a polar molecule. The picture down here describes the partial positive charge of the hydrogens because the dipole moment is being pulled towards the oxygen. So overall, we have a dipole moment because of that strongly electronegative oxygen. Water molecules, if they get next to each other, have hydrogen bonds, which, if we remember, is a hydrogen that is next to a fluorine, an oxygen, or a nitrogen. So if we have two water molecules next to each other, the attraction is between the molecules. So we have a polar covalent bond between the atoms, but we have a hydrogen bond in between molecules, which we call the intermolecular force. This is a specific type of dipole interaction that is stronger. Water, as you may know, has a high surface tension. Surface tension is the inward force or pull that tends to minimize the surface area. So if we didn't have strong surface tension, a drop of water on a table may look something like this. But instead, we have this strong inward pull called cohesion of the water molecules, which pulls in to a droplet form. And because of that, we have a spherical shape, because that is the best surface area to volume ratio. Water surface tension is stronger than most liquids. Surface tension reduces vapor pressure. So sometimes on the surface of water, you'll see little bugs that are jumping around, and that's because the ability to break the surface of water can be tough if you don't have a whole lot of mass. Evaporation occurs on the surface of a liquid. If we have a high surface tension, it's very difficult for these water molecules to escape the surface and vaporize. So we don't have a high vapor pressure with water. Substance called a surfactant is something that interferes with the hydrogen bonds between water molecules. And because there's interference there, the surface tension breaks down and the water spreads out. So here's a picture of water molecules all together. They have hydrogen bonds all over the place, but when a surfactant gets in there, you'll see that these surfactants get in there and disrupt the hydrogen bonds, and it breaks down the surface tension. So where you would have a sphere of water like this before, you may have something not as spherical afterwards. So examples of surfactants would be soaps and detergents. And what you might need to know is that soaps and detergents, surfactants, have one side that is polar and one side that is nonpolar. And because of this, they can attract not only to water, but also to nonpolar substances like oil. So if we watch this animation, we'll see how the oil droplets and the water molecule droplets are both attracted by the surfactant. The nonpolar ends are attracted to the oil. The polar ends for the sulfate are attracted to the water molecules. And so what we form around oil droplets are what we call water spheres. So when you're washing off dirt on a plate, you're actually just allowing the surfactant to surround the oil drop with water so that you can wash it down the sink. True story.